Hey everybody, here we are in section 11.7. We're looking at part 2. We're going to finally use this binomial theorem that we were only talking about in the last video. So let's check it out. We are expanding a minus b, that binomial, to the sixth power, and we're going to use the binomial expansion theorem in this form. This is the form I want you to copy down. So check it out. If I have a minus b to the sixth, that means 6 choose 0. We'll talk about that. That refers to this little part here. And then we have a to the 6, and watch this, negative b to the 0. You didn't see that. This is a minus b. That's a plus b. That's why they just have b to the 0, but we need to do negative b to the 0. Let's keep going. This part will be 6 choose 1. And then we'll have a to the 5th power, and you got it, negative b to the 1st power. And then again, we'll do 6 choose 2. And then we'll have a to the 4th power and negative b to the 2nd power. And then, you got it, 6 choose 3. A to the 3rd, negative b to the 3rd. Let's get that 3 there. And let me see if I can move that over and shrink it a bit. Okay, so negative b to the 3rd plus 6 choose 4, a to the 2nd, negative b to the 4th. As a's power decreases, negative b power increases. 6 choose 5, a to the 1st, negative b to the 5th. I don't know if I'm going to make it. And then stay with me, everybody. 6 choose 6, a to the 0, and b, negative b. Oh, let's try again. Okay, let's try it. This final one is 6 choose 6, a to the 0, negative b to the 6. And now we've got to unpack this. So what do these coefficients mean? These highlighted values will be calculated using this relationship here. So let's go ahead and do the thing. So the top number, the n factorial of the top number, r factorial, and then the factorial of the difference of the two. So we have 6 factorial over 0 factorial. By the way, we never talked about this. I'm sorry, bad teacher. 0 factorial is defined as 1. The argument and explanation is a little, it's not heady, it's interesting. There's a wonderful little video on, it's not number file, I forget what it is, but it's on YouTube. Feel free to check that out. So 0 factorial there, and then 6 minus 0 factorial is just 6 factorial. You see where this is going. So basically we have the same thing over the same thing, because this is 6 factorial, that's 1, this is 6 factorial. So basically we have 1. So our first term is a to the 6, and that's it. And we knew that was going to happen. I'll do 1a to the 6 just to emphasize the point. Our next term, let's go ahead and calculate that, will be 6 factorial over 1 factorial, which is also 1, and then over 5 factorial, because it's going to be 6 minus 1 factorial. So let me write that down. So 6 factorial over 1 factorial over 6 minus 1 factorial. And so the equivalent is that this is not 61, but 6 factorial over 5 factorial. You guys with me on that? And if this is 6 factorial over 5 factorial, then this means this is 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. And so basically, let's should write that down. This is what it looks like when I expand it. And I could have put the 1 here from the 1 factorial, but you know, whatever. The fact is that all of this cancels with all of this. Take a moment to think about it, and we get that our coefficient is 6. Now this is now sloppy, so I need to move some things around. But we just saw that this ended up giving us 6, so I'm just going to put the 6 there. And what is the 6 next to? What is the 6 the coefficient of? A to the 5th and b to the negative b to the 1, which would end up being a negative b here. But what that's going to do, I know you guys are like, what is she doing? It's going to make this whole term negative there. All right, so this coefficient came from 6 choose 1. We worked that out just a second ago. A to the 5th times negative b to the 1, that negative b affected everything. And we're just going to keep going. All right, so this is going to be 6 choose 2. So that's going to be 6 factorial over 2 factorial over 6 minus 2 factorial, which is 4 factorial. And then so the same situation applies. However, 2 factorial is 2 because we're doing 2 times 1. This is going to be 6, I'm trying not to write too much, but 6 times 5 times 4 times 3 times blah, blah, blah. You already are thinking 4 factorial is 4 times 3 times 2 times blah, blah, blah. And you're right. These guys cancel out, and I'm left with 2 factorial underneath 6 times 5. Well, 6 times 5 is 30. 2 factorial is 2. That coefficient is 15. So now I have 15 as the coefficient, and that comes from this business here, the 6 choose 6 choose 2 rather. And then I need to deal with what's happening here. Well, we know it's a to the 4th. As a decreases, negative b increases in power. So this is negative b to the 2nd, but negative times negative is a positive, so notice the sign doesn't change. And so you can kind of anticipate what's going to happen. Each of the sign is going to flip-flop change. Positive, negative, because as we raise a negative to an odd or even power, that sign's going to change. And so we're going to keep going. This one is going to be 6 choose 3. And when we follow the law, 6 choose 3 will be 6 factorial over 3 over 3 factorial times 3 factorial. So you guys get that. That's 6 minus 3 here. That's where we get that second 3 factorial. And then so we'll rock it out. We know that 6 factorial is 6 times 4 times 6 times 5 times 0 times 3 times 2 times 1. And then 3 factorial is 3 times 2 times 1. Therefore, at the top, if I reduce these guys, I'm going to get 6 times 4. 6 times 5, I can do this, guys, I promise. 6 times 5 times 4, because the 3 times 2 times 1 canceled at the top and bottom with one of the 3 factorials. And then I'm left with 3 times 2 times 1 with the last factorial. You guys with me? I know you are. I know you're getting this. You're like, this is wonderful. And so I could do a little bit of cancellation. I could also pull out a calculator, but who wants to do that? You might want to. That's okay. So I'm ending up with 2 times 5 times 2, which is 20. So this coefficient is going to be 20. We got that 20 from 6 choose 3, and we calculated it down here. The coefficient is going to be a to the 3rd, reducing the, not the coefficient, it's going to be, 20 is going to be the coefficient of a to the 3rd, negative b to the 3rd as well. And that's going to turn out to be making the whole thing negative. So instead of leaving the negative next to the b, I'm going to make this whole term negative. I'm going to keep going with this. I'm hoping that it's making sense for us. And then so this is going to be 6 choose 4, and you're going to see it. So if I do 6 choose 4, right? 6 choose 4, so 6 factorial over 4 factorial over 6 minus 4 factorial is 2 factorial. Look what happened. We reached the bend. So here, I know that I got the same thing. These are the same things. You guys with me? So now I know that this is 15, coefficient, a to the 2nd, b to the 4th. The reason why I put b to the 4th there as opposed to the negative b is because negative b to the 4th power is the same as b to the 4th power because it's positive and we deal with the negative already. This next term is going to be, the coefficient is going to be, you see we're doing 6 choose 5. So if I'm doing 6 choose 5, that means it's going to be just like 6 choose 1. It's going to be like this guy over here. So 6 choose 5, it's going to be 6 factorial over 5 factorial times 1 factorial. We've already done that before, so I know that's going to turn out to be 6. This is going to be a to the 1st power times negative b to the 5th power. Negative b to the 5th power will be like b to the 5th power, but negative. So I'm going to change that term, make sure it's negative. And then finally, 6 choose 6 is going to be like 6 choose 0, in that we're going to end up with 6 factorial over 6 factorial times 0 factorial. 0 factorial, we remind you, is 1, and therefore 6 factorial over 6 factorial altogether is 1 because it's the same thing over the same thing. And finally, my friends, I have a to the 0, which is 1, so I'm not going to put that down. Negative b to the 6, which is the same as positive b to the 6. And there we have it. I think the talking about it is what took long here. This is a shorter process than going through and writing out all of Pascal's triangle to get to a particular line, even though it may not seem like it right this second. And the beautiful thing about this theorem is that if somebody said to you, expand this and tell me, expand something crazy and tell me what the fifth term is, you can go directly and find that fifth term. It's almost like the difference between a recursive formula versus an explicit formula. So this gives us an explicit way of getting to a particular term. Because I taught you a different way to actually expand it and I told you a different way out of order, this is like the lamest example for us at this point because you guys are like, we already did this, we know how to do it. And I get it. Knowing that 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I know I don't have to write that out for you guys, but sometimes I feel like there's something visually satisfying about seeing all of that. And that 5 factorial is that, and 3 factorial is 3 times 2 times 1. I like just canceling out very quickly and then dealing with the remnant. And you saw me do that in the last example. And so that's how I'm dealing with this problem. And you see me kind of cross-canceling in a sense. So this is going to be 7 times 4, which is 28 times 2, which is going to give us 56. Our final example, let me not lie, no, our almost final example, I'm sorry babies, is going to be expanding this thing. And so here, what I want you to see, so we're going to use our binomial expansion theorem to do exactly that. We're going to expand. And so I'm going to save you the drama, but what I do want you to know is that A is 2x and b is y. So we're not going to get the terms that we got last time, but you'll see. So here I expanded it out. Go ahead and pause it, take a look at it, make sure it makes sense to you just using the things there. Notice that both of the terms are positive, so we're not going to have that flip-floppiness of signs, that plus, minus, plus. And so it's not that the terms will be different, but you're going to see that the coefficients are going to be different. Like this coefficient isn't going to be 1, even though 5 choose 0 ends up being 1. But what happens here is 2 times x to the 5th power is 32 x to the 5th. You see what I'm saying? Y, not y, 32x to the 5th, y to the 0 is 1. So that's my first term, is 32x to the 5th. I'm going to keep going down the list and calculating. So this is going to be 5 factorial over 1 factorial times 4 factorial, which is just going to leave us with 5 times 2 times x, 2x to the 4th power, which is going to be 16x to the 4th. And that's going to give me 1y plus, you see where this is going, right? 5 factorial over 2 factorial over 3 factorial, which leaves me with 5 times 4 over 2, which gives me 10. But then I'm doing 10 times, this is 2x to the 3rd power, which is 8x to the 3rd power. You see this, guys? You see the crazy? So I'm going to finish this, which wasn't hard at that point because we started reaching that palindrome effect where 5 choose 2 is the same as 5 choose 3. If you remember, like we had that last time, therefore this is 10, 5, and 1. But I've got to figure it out by actually calculating. So I'm going to calculate each one of these. And so just by simplifying each of these terms, by doing the multiplication required to simplify, this is what we end up with. Okay, so I'm going to do this final example so we don't have to do another video. Find a particular term. If I've got PQ, find P plus Q. I want to find the 5th term of that. So let's go ahead and look at our expansion. So by considering this formula, our 5th term will look like this. It'll be N, which is 10, choose not 5 but 4. Notice our first term is 0, so it'll be n choose 4 times p to the 10 minus 4, so that's p to the 6. And then to make up the difference, it'll be q to the 4th is what we're dealing with. Let's calculate. 10 choose 4 ends up being 210, and that's our 5th term. Guys, it's been a pleasure.